Assalamualaikum. I am Mrs. Roslinda binti Ismail. Today we will continue our lesson in PLC and automation for chapter 2. The chapter 2 is about logical sensor. Do you know it? Definition of sensors. Sensor is a device that changes in physical stimulus and turn into measurable signal. Meanwhile, the logical sensor can only detect a state that is either true or false. What is the physical phenomena for logical sensor work? There is 4 key points for the physical phenomena. First, metal. Is a metal object nearby? Second, light. Is an object breaking light beam? Third, dielectric. Is a dielectric object nearby? And fourth, touch. Is an object touch a switch? Types of logical sensors. First, contact switches, which is detect object that touch the switch. Second, proximity sensors, which is a device that detect presence of an object without physical contact. And last, photo-optics, which is the object being detected breaks a beam of light. Example of logical sensors. First, contact switches, which can be limit switches, push button or rip switch. For the proximity sensor, it can be capacitive or inductive proximity sensor. For the photo optics, it can be an object which can breaking light, reflecting light or diffuse light. Types of proximity sensor can be inductive proximity sensor, which can detect metal object only, and for capacitive proximity sensor, it can detect metal and non-metal object. Did you ever wonder how an inductive proximity sensor is able to detect the presence of a metallic target? Inductive proximity sensor basic operation which can detect metal object only. From the figure given, it consists of a coil wound around a ferrous metallic core. It uses currents induced by magnetic field to detect nearby metal object. The measuring inductance sensor only can detect when metal object have been brought nearby. Inductive proximity sensor building diagram as shown in figure. When a piece of conductive metal enter the zone defined by the boundaries of the electromagnetic field, some of the energy of oscillation is transferred into the metal of the target. This transferred energy appears as tiny circulating electrical currents called eddy. Upon detection of the target by the Smith trigger, the sensor's output is switched on. And now, what is a capacitive proximity sensor? Capacitive proximity sensors are non-contact devices that can detect both metal and non-metal objects. Capacitive sensing technology is often used in other sensing technologies such as flow, pressure, liquid level, spacing, thickness, ice detection, shaft angle or linear of position, dimmer switches, key switches, XY tablet, and accelerometers. Principle of operation inductive proximity sensor. From the block diagram given, it shows that a capacitive sensor acts like a simple capacitor. A metal plate in the sensing phase of the sensor is electrically connected to an internal oscillator circuit, and the target to be sensed acts as the second plate of the capacitor. Unlike an inductive sensor that produces an electromagnetic field, a capacitive sensor produces an electrostatic field. And now, what is a photoelectric sensor? A reflective type photoelectric sensor is used to detect the light beam reflected from the target. A photoelectric sensor emits a light beam, visible or infrared, from its light-emitting element. A reflective type photoelectric sensor is used to detect the light beam reflected from the target. Three principal and major types of photo-optic sensor. First, true beam model. Second, reflective model. And third, retroreflective model. For the reflective model, you can see from the diagram, it shows that a beam of light is emitted from the light emitting element and is received by the light receiving element. Both the light emitting and light receiving elements are contained in a single housing. The sensor receives the light reflected from the target. Meanwhile, for the true beam model, the transmitter and receiver are separated. When the target is between the transmitter and receiver, the light is interrupted. And last, the retroreflective model. Both the light emitting and light receiving elements are contained in same housing. The light from the emitting element hit the reflector and return to the light receiving elements. When a target is present, the light is interrupted. That's all from me. Thank you.